in terms of the materials that we take on. So things like road sweepings and gully waste, which have residual hydrocarbon in there, heavy metal, and a lot of organics, up to 40-50% organics in the autumn time. These are kind of input materials which we now look to washing.
We've had a system in Long Island for over 5 years. They're going to approach a decade real soon. It happens like that. But they took a gamble. They had a problem. They found us in Vegas, and we had a solution, a ready-made solution ready for them, and they took a gamble, and they've been very successful since. And it's a gold star on the first CDE, within the U.S. market. We've duplicated that a couple of times now. We have a system in Canada that's going to be doing heavy hydrocarbons and oil, not the oily sands, but it's up there in Calgary, and then we'll have another facility on the East Coast as well, coming online real soon, that will be doing something just like our Long Island facility.
It's a United Nations project which has really run a long time, and soil washing technology was identified as one which with low ESG environmental impact for the remediation project. It also left the biological integrity of the soil intact, so the sand coming out of the plant of the washing system can go back into backfill, can go into revegetation. We don't kill the bacteria from our system, and we don't need heavy chemicals within that system as well.
Hi everyone, welcome back to episode 5 of Talking Tons. In today's episode, we're going to be discussing contaminated soils, and with our panel of experts, we're going to talk about some of the innovative projects we've delivered for customers globally. Talking Tons with us today, we've got Thibaut van de Cleve, who's our Business Development Manager for France, Belgium and Switzerland. He brings 20 years experience in the environmental solutions industry across Europe and North Africa.
Next up, we have Andrew Wilson. Andrew has been with CDE since 2017. Andrew has particular experience in soil contamination and remediation across Europe and the Middle East. And then finally, we have Joe Taylor. Joe's Business Development Manager for the Americas and has grown up with a family business in the construction industry in New Jersey. So I hope you'll be able to share some of that experience with us as we chat today.
As much as I can.
In this episode, we're going to talk about the restoration of contaminated soils. You might know this as soil washing or soil remediation. And I suppose, seeing as we have such a broad experience globally around the table today, it might be nice to just kick off with looking at what that looks like around the world. Joe, you might just explain to us what the situation is in the US.
Yeah, the US we've had a couple systems in the US for 7 years now. A lot of people took a big risk with us, just recognizing the market. I mean, in heavy urban areas, heavy industrial areas, there was just a lot of contaminated soil just by virtue of these companies dumping in the Hudson River, or just, having a chrome, doing the chrome plating and just having a big hole and just dumping right into it. And then that leaches out in the soil. And then as suburban America continues to expand and technology expands, you're finding out that these things are contaminating your bloodstream and everything. And what do you do with it? Where do you go? So the market is right for the picking. Our solution is very successful. And it's exciting, that's why I joined CD, when Darren Eastwood, talked to me 4 years ago, and I had no idea this was even an option. And, bam, I gravitated right to it, and I was happy to join the team. Rick.
I mean, I think it's one of the fastest growing sectors for CD as contamination generally. The business started over 30 years ago in material washing. That was primarily sand and aggregates. Over 20 years ago, the business was getting into construction demolition materials, and we find the challenge gets greater and greater as time progresses in terms of the materials that we take on. So things like road sweepings and gully waste, which have residual hydrocarbon in there, heavy metal, and a lot of organics, up to 40-50% organics in the autumn time. these are kind of input materials which we now look to wash in. So it's interesting because I suppose it's quite traditional techniques in terms of washing, but it's applying them into contaminated waste streams. So it's utilizing different technologies, bringing them in, often looking at the water recycling as well, to remove any contamination which is staying within the water loop. And this is growing for us. I mean, I think it's growing because the understanding around the contamination is just exponentially growing. You know, like nobody was talking massively about this 30 years ago or so. And as Joe mentioned, the amount of land which is actually contaminated by industrialization is mind-boggling. And also that coupled with the evolution of the technology. So now the understanding that, you know, certain technologies can remediate that land from X to Y, you know, is increasing the confidence in customers to deploy solutions and take on these markets. I mean, we're involved in the full gambit, I would say, of contamination or what applies to soil washing. You know, whether that's hydrocarbon contamination or organics contamination comes to us a lot, heavy metals as well, and fairly recent new types of contamination which are really grabbing a lot of attention, such as PFAS. I know, you know, PFAS is a problem everywhere, but certain parts of the world, you know, seem to be really moving in the direction of processing. Benelux was one of those areas.
That's correct. That's correct. Andrew, the market in France, Belgium, Switzerland, we have probably the likes of 12 to 15 full-size wash plants. Probably nearly half of it are dealing at some point with contaminated soils. Some are only processing this material on a daily basis. Very specific to the region, north of Belgium especially, is dealing with PFAS remediation. The legislation has been there, being drastically increased in terms of the tolerances they can deal with. At the moment, really, Flanders in Belgium is a key driving region for PFAS remediations, and PFAS has been a problem there for decades.
It's probably worth mentioning as well, Thibaut. So, I mean, the PFAS problem that comes from a variety of different industries. You know, one of them was a lot of manufacturing waterproofs for waterproof clothing, for example, coatings for pants and so forth.
North of Belgium, if you go to the seaside, there's a lot of heavy industries, a lot of chemistry, and there was a plant that was using a patent to create PFAS as a core product that would be used in as you said, in the paintings, in the Teflon, the pots, waterproofing, anything, and it's been on for 20 years. Everything there is connected with canals. It's a very flat country, and PFAS travels very easily, migrates into the water, and as a consequence, anything connected to that part of the country, I'm talking about the city of Antwerp, anything connected to that is potentially contaminated. So the legislation there is like, if you excavate certain amounts of tons of soil, you need to seek for PFAS.
So regardless, it has to be tested?
Yes.
So that's something in my market with PFAS. Yeah. From Philadelphia to New York City to Boston, there's concentrations, hotspots, but ultimately it's not an emerging contamination anymore. They're actually putting figures on what's considered contaminated and what's considered clean that you could reuse or something along those lines, and still a moving scale. But the technology that we're bringing to the table, the Europe, will be brought to the States eventually. We just have to figure out just where that number is.
It's really if you never look for a contamination, you will think that some inerts are inerts, but they're probably like contaminated. I recently took some of our new customers from Belgium who will soon have a PFAS remediation plant. That's about to be live, and material on ground date is around June this year.
So sand on the ground in June?
Yes.
It's a brand new PFAS.
Brand new PFAS, the latest state-of-the-art plant process we thought about together. So we took them to a site visit only 40 kilometers away in France, north of France, and they saw that plant processing inerts, and they were the first question they asked if how confident are you that those soils are not contaminated with PFAS? Because you only cross the border. The border is probably 10, 20 kilometers away, and yet you have to seek for PFAS, and fairly easily, most of the time, the soil will be contaminated.
And they're still selling their sand.
Yeah.
Both those plants are selling their sand.
And I mean, you touched on that point as well, Joe, about, the confidence in the output materials, and really, do you want to wash this soil? Will it achieve the right result? What would you do with the outputs? You see that evolution within Europe. So the PFAS topic was really has been very hot for quite a while, but it was mostly on the water treatment side of it. So, runoff for dealing with the runoff from landfills or contaminated sites. How do you, take that PFAS out of the water phase, and increasingly now it's looking at actually the physical soil. Well, how can you remove that PFAS from the soil? And I mean, within Europe, there's a lot of confidence now in terms of washing as a solution for PFAS soil. So you see companies having great success with washing technologies, and others, jumping on that on that bandwagon.
And our system and our technology does not really care if it's long chain or short chain, or if the PFAS or PFOS. We understand that our technology will get it from the soil into the water, and we're very successful with that. Yeah. It's just really, I guess, kind of like the business model really comes down to a certain market. Yeah. In the sense of, because in presently stated, I mean, things are changing. It's a moving scale, left and right. No one's really taking this is exactly what we're going to be doing with this in terms of permitting and legislation. But it's testing for PFAS is very expensive. So you have that piece. So it's not that they don't want to test. Is if you're good at tests, you have to have a reason for it. Yeah. And then with the way that the regenerated sand, recycled sand, there's that anecdotion, that piece to it. It's like, well, that was soil with PFAS in it. Why would I reuse that? But it's, a test makes all the tests.
Yeah. That product is in many different processes. It's been used for ages in many processes. Like I'm thinking about firefighters, extinguishers powders is full of PFAS. So anywhere where you have firefighters doing some
was a shelf life to it. That's what I was finding. And airports with
yes, in the airport,
that Australian project Ventia. That's how that was all.
Yeah, that was the key, the key starter for us. It just started us looking at PFAS remediation, and it was a training boot camp for firefighters and next to an airport.
Yeah, they sprayed pure PFAS all over the ground.
And
20 years.
That's common, and you see that split. So we talked around Antwerp about the manufacturing process and how that has produced contaminated soil with PFAS, and the military is another big chunk of that. So both
Air Force bases,
and also just domestic airports as well. All that firefighting in the past, a lot of it was done with PFAS contaminated soils. So we tend to see a bit of a split there as well, with waste management companies wanting to process PFAS contaminated soils from excavation projects, and then at large tender projects with aviation authorities or the military to remediate contaminated ground around those airports.
It's exciting in the sense of I feel really good about talking to people that are trying to solve this problem. It's a challenge worldwide, but we're coming here not blaming anybody. We're coming with an option to handle this.
But what's very very strange with PFAS as well is that there's a French analyst who's been trying to gather informations about sampling points all across the country, just to seek for PFAS. Because as I said, if you're not looking for any contamination, you won't find any contamination. But he's been trying to gather as much information as he could, and sometimes away from any industries, like in the middle of nowhere in France, you hit a very high threshold of PFAS. You got contamination in the middle of nowhere. So ultimately, we believe that that is a Flanders problem at the moment will spread to the south of Belgium, Luxembourg, Germany, and France, probably all across Europe at some point.
Just doing a mass excavation.
Yes.
And just excavate it all and cut the head right off the snake and take care of it.
It's probably going to be a case by case scenario, but when you in Flanders, when you excavate, I think it's more than 5 tons, you need to analyze and seek for PFAS. Probably that would be the trend in other places.
Yeah. Well, for us, like in the States, presently stated, it's a pack I passed the smell test. If you know as an environmental engineer or a property owner, known that piece of land was exposed to PFAS or around a canal or something like that, you're expected to test for it. But again, if it passed the smell test, then it is costly. It's not only costly to test for it. If it tests positive for it, then you got to handle it as a PFAS or related material.
I suppose maybe moving on maybe a bit from PFAS.
Sure.
There's some other applications that we're working in that's really interesting. One of those is the oily sand space. Is that something to maybe tell us a bit about?
Yeah, Andrew, tell us not the hands full with that for a while, actually. Yes, yeah. But that's interesting because it's not CDE's core business over the years, but it's again like PFAS, an example of the flexibility of soil washing solutions, really, and how you can adapt to certain types of contamination and problems. So a project which really stands out for us is in Kuwait. There, after the Iraq war, some people might remember, there was a huge environmental disaster. So when the Iraqi forces retreated, they bombed a lot of the oil wells, and this produced a big spill of crude oil over the desert. So 114 square kilometers of land was contaminated with crude oil. If you remember the footage from back then, or if you YouTube it, the sky was black, and they had a big challenge to put out these fires to start with, because nobody had encountered, multiple oil wells on fire at the same time. Joe, you like this one? So they had firefighters from, all over Europe and Australia trying to put out these fires, trying various methods with sand.
Ultimately, they had to use bombers.
They bombed the well, so they bomb it, and this would extinguish the fire and allow the firefighters to get in there. That was the US guys who pioneered that. Yeah. So this was a United Nations project which has really run a long time, and soil washing technology was identified as one which with low ESG environmental impact for the remediation project. It also left the biological integrity of the soil intact, so the sand coming out of the plant of the washing system can go back into backfill, can go into revegetation. We don't kill the bacteria from our system. And we don't need heavy chemicals within that system as well. So we installed 2 of those systems into Kuwait for that project, and more recently in Saudi Arabia, we also have a plant with a waste management company. And again, that's you know, a little bit what I was talking about. We have environmental disasters, be it from war or from
Natural disasters and stuff.
exactly. Yeah, the whole, that whole gambit, these super funds, and then you on the other side have general production waste, which also needs processing.
I think you use a pilot plant to develop the solution for.
We did, yes, yeah. I mean, again, that's going through this the contaminated soil. There's rarely one solution, so every project is taken on its merits, and the projects are relatively bespoke. And you know, that started in our lab, really analyzing the material. You know, looking at how we could treat it, what technology and factors would impact it, whether that be heat, chemical, physical techniques, and then from that scaling up into a lot.
That's the biggest challenge, is scalability of the solution you're creating in the lab with the pilot plant, and then
It is, yeah. And we try to use proven techniques. So the core of our system is really our bread and butter, and what we're using in a variety of industry. It might be a technology which we took from silica sands or iron ore processing. Or
Access. I'm just being naive. This is a desert. Do they have access? Like, do they have ready access to water, or is it difficult to get access to water in that parts of the world?
Yes, it's very difficult. Yeah, and that's always a big part of the discussion within our plants. How much water does the plant need? And how can you minimize that water consumption? And that's something which we've prioritized from a very, very early stage. All of our systems have full water treatment and recycling. You always lose some water, because if you're taking dry material in, when it's dewatered at the end, you have some residual moisture. In the Middle East region, we even developed a system to combat that, where in the stockpiles we can remove some of that residual moisture to really minimize
Drainage water.
let it drain as long as you can to retrieve the water. That's the key.
Exactly. Yes, that's a lot of miles tankering water around the desert.
That's exciting stuff. I mean, I've been with CDE for 4 years, and just one of the first things that I learned about just riding the car with Darren and other CDE members, and like that just blew my mind, honestly.
Yeah, we don't have oily sands in our region, so yeah, we're always curious when you develop something that how much can we learn from it, and can we use that for another material somewhere else.
That's it. I mean, and you can apply all the know-hows to other materials. I mean, this, the system in the US, Joe, you sold, I know they were processing some hydrocarbon impacted soils, and a big point on their ROI or return on invest was the logistics on Long Island. You're trucking that material.
Yeah, we've had a system in Long Island for over 5 years. You know, they're going to approach a decade real soon. It happens like that. But they took a gamble. They had a problem. They found us in Vegas, and we had a solution, a ready-made solution ready for them, and they took a gamble, and they've been very successful since. And it's a gold star on the first CDE, within the U.S. market. We've duplicated that a couple of times now. We have a system in Canada that's going to be doing heavy hydrocarbons and oil, not the oily sands, but it's up there in Calgary, and then we'll have another facility on the East Coast as well, coming online real soon, that will be doing something just like our Long Island facility, but they're adding some newer technology to it, and I hope so. We improve every year, right? Every generation of our solutions are getting better, so they're going to have the ability to separate brick. So on a commercially, they're going to be able to separate brick from the inbound, because in that area on the East Coast, you have historical fill. So you're getting contaminated fill, you're also getting historical fill, and that's hundreds of years of just older cities just getting demoed and then built up on top.
Yeah.
So you get brick in just backfill.
Yeah, that's broad. Yeah, that's a brownfield. It's not a greenfield. So you build on something that was built before. So the demolition, reconstruction, the core aggregates you find in the ground are fully contaminated with bricks and ties and residue.
And contamination isn't just like a substance. It's your metals, it's your plastics, it's your organics, it's everything. And it's really I think our solution is top notch, first class, every single time. It's a pleasure working and I'm really seeing our solutions.
I think maybe just to touch on something that you mentioned there, Joe, was the commercial side of things. So a lot of the solutions we've talked around there have been driven through, the environmental benefits. You've mentioned there around the brick. And is there any other kind of, when we think about the commercial side of things, how does it stack up?
So in my region, there's a few things that kind of alter the whole commercial side of it. And it's all about sand scarcity and distance for transportation and the cost of that transportation.
Yeah.
And that's just on outbound, sand and aggregate sales. But then on the inbound, the gate fee or the tipping fee, however you want to, it's, that becomes very expensive, because if you're going to go develop a new warehouse or expand a road and you excavate and all of a sudden you get contaminated soil, where do you go? There's really only so many solutions.
And sometimes you can't transfer some contamination on the roads. I'm thinking about slag on the steel plant.
Right.
It has to be processed where it's produced. So sometimes the solution needs to be next door
Right there.
or on the site.
Well, and then commercially, the cost of remediating soil, even if it's a brownfield site where that material can stay on site, you still have to import clean materials. So,
Yeah.
So with a solution like ours, we're a one-stop shop. You can, I'm a business owner. I'm putting up a CDE client. You're going to get I'm going to be 10 miles closer to you, to your concrete or asphalt plant or your hole. You come to me, I'm going to clean it up, and I'm going to provide you clean aggregate and sand for your next development or road production or concrete production. It just makes so much commercial. But then on the other side of that, we add benefit, we add value to the commercials in the sense of these environmental product declarations, these EPDs. Yeah. So in America, they're targeting asphalt, concrete, glass, and steel. You have to have these EPD numbers, as a product. So your concrete has an EPD of this number. Your concrete has EPD this number. It's in stages: stage 1, stage 2, stage 3. Stage 1 is extraction, and you have to account for your concrete has to account for what's happening in the sand mine that could be 100 miles away, and how they do it. Are they dredging, or are they bulldozing? And how are they excavating with a haul truck? Yeah, you have to calculate all of that, all the way up to your concrete. We eliminate stage 1 and half of stage 2 in the sense of transportation. So we benefit. Now we're making, and on top of those EPDs on the commercial side, you're going to win contracts based on your EPD score versus your price per ton, or your price per yard, or your cubic meter.
Yeah. I mean, I think, as you mentioned, it's about closing that loop, really. So if you've got a situation where you're driving materials outside of the city to tip it in a landfill, and then you have a quarry where you're bringing raw materials into the city to manufacturing, for civils or for construction, the washing plant can essentially close that loop without those extra logistics. And the other part of that really is to produce high quality aggregates for reuse. So we don't look at downcycling. We really look to maximize the quality of the product. So that means you have a sand and aggregate which can be used in concrete applications, construction applications. It's not about washing a low quality product to fill a hole.
It's probably worth mentioning also that we probably have 30 clients with full-scale wet processing applications dealing with contaminated soils. As
purely contaminated.
Yeah, purely
contaminated.
And quite often, it's important to know that I'm thinking about one client in France. He would welcome any contamination on his land, analyze it, and wash it until it's clean enough to be used in concrete applications. And that's his core business. So it would welcome metallic contaminations, hydrocarbons, PFAS, anything, and use our wash plant to access to good products. It's important to note also that some of our clients, they have the process inerts, but they could only add a few, just that brick that would enable them to process contaminated soils as well. So it's just another tiny break you add to what they have at the minute that would really enhance the solution, the level of solution they have, and would open them to plenty of other markets. So
yeah, and especially with where I live and where we operate in New Jersey and Pennsylvania, you know, you have so many people that are so tightly packed in that, you know, there's, you know, sand and aggregates have to come from further and further and further away. Yeah. So, you know, a CDE solution really jumps that. And I've always said this, there's harmony. You know, sometimes I feel like when we're talking to people that are sand and gravel miners, and that's been their family business, that we're here to steal their show. No, there's a harmony. I want to protect that beautiful virgin sand that's in the, you know, for the Jersey Shore. You know, I'm reuse what can be reused, because we do make a regenerated sand. I don't like to say recycler because some people get scared of that. It's a regenerated sand because the sand is already there. We just regenerate it. So that, I mean, it's a fun business to be in.
It is exciting. And, you know, I think we all agree, you know, the trend for the future is more recycling to higher qualities. You know, you see peaks and troughs in various markets, but the general direction seems fairly clear worldwide.
Yeah, reduce the level of volume you send to landfills is key, but also protects.
We didn't even talk about landfills. I mean, that's for me, we have landfills closing all over the place. Like Long Island, for instance. Yeah. No more landfills, probably another 18 months.
But the biggest part, to open one. I mean, how do you open it? To open the landfill now is tricky.
And that even doubles down because it has to be further and further away from where the garbage. I mean, for instance, New York City, it's a very high number. North of 85% of their residential garbage gets on a train and goes to Ohio. Thousands of miles away.
If you look at Europe, like sometimes countries, they work like this. Luxembourg, Switzerland, most of the volumes they produce, they go away from a country to France, Germany, whatever. But they just don't deal with it,
right?
And that's what they do. So
it's such an exciting topic. So I'm sorry to have to maybe cut the conversation short. We could keep talking. It's is there before we wrap up for today? Just want to thank everyone for their time, and is there any kind of final thoughts we want to leave people with before we close off our episode today?
It's just the fact that probably think that contaminated soils processing in the side of solutions, it opens a lot of potential markets to our customers, and opens a lot of probably a bright future for CD as a solution provider, because we have a state-of-the-art plan for in many ways, and in some parts of thinking about PFAS, we got a solution that is really upfront of the problems, and it would solve many issues on territories like Europe, the US probably as well, and that's probably